Hi, and welcome to a new episode of TLDR, CISPA's first podcast series. TLDR is short for Too Long Didn't Read, and we named our podcast that way because we want to save you the hassle of reading long research papers. Once a month, we talk to our researchers and try to get them to explain their work in a way that even I, not being a cybersecurity researcher, can understand it. Speaking of me, my name is Tobias Ebelshäuser from CISPA's Communication Department, and joining me today is Dominik Wermke. Dominik is a PhD student working in Hannover at CISPA Satellite, as we call it. The Satellite is a dependent branch of CISPA in cooperation with the Leibniz University in Hanover. Dominik is originally from Cologne, but he's no stranger to CISPA's home, Saarbrücken, as he already did his bachelor's and master's there. Today, I'm going to talk to Dominik about software supply chain attacks and open source software, and why that name might actually not be all that appropriate when it comes to open source software. So, hi Dominik, thanks for being here, or rather, thanks for having me, as I'm now a guest at your office in Hanover.
Yeah, hi. Glad to be here. Or great having you here, I guess.
Thank you. So, Dominik, let's dive right in and let's talk about open source software. What is that?
Yeah, sure. So you already opened the first problem, I guess, because the answer depends on who you ask. Because there are philosophical components to it, there are access components to it, there are license components to it. So I guess I just want to break it down for what we considered in our research, and because we are interested in the security and in who uses those open source components, we mostly just consider open source to be software that is in some form publicly accessible and that also receives contributions from the public, or can at least receive contributions from the public.
Is open source software always free, or can it also cost money, or is that part of the definition?
I guess for some definitions, but not generally. There are many open source projects that in some way raise money by either providing support for their platforms, or that have premium components that you pay for, or that you can host for free yourself. But if you want to have a hosted version, you can also pay them. So I guess it's not generally free or paid or in between. It's just mostly if the source code is available or not online in some form.
Okay. And where is open source software being used?
Basically everywhere. From let's say if you're using a phone, you're probably using some form of SQLite on it, which is an open source database. Or if you're using any embedded device, it was probably compiled with open source compilers in some form, or includes open source libraries. So if you executed any form of code today, you probably also executed some form of open source component with it.
What is an embedded device? What does that mean?
That could be basically anything in chip form, from your heat measurement device to your smart light bulb or your smart plug or anything in between.
Okay, and they all use some form of open source software.
So of course I'm not sure if the specific device uses it, but in general, yeah, they probably used some form of open source at least in their tooling or in their design or in their libraries, probably.
Okay, so basically any large company that exists uses them in their code. I don't know, if I'm using a music streaming service, do they use open source software in a way?
So yeah, if they're a software company, they definitely have used some form of open source probably in their products and their their website and their tooling and the development setups. Yeah, there's probably some open source component somewhere in there.
In your current research, or in your latest research, you decided to look into open source software. Why did you decide to look into that specifically?
Yeah, you already covered, I guess, the important points, and the most important point is that it's basically everywhere. So if you are looking for a user of open source, you can basically ask any company in some form. They probably have some open source somewhere around. And also the other interesting point is that open source brings unique challenges compared to other, let's say, paid software or bought-in software, because getting back to the our definition, if you have some open source repository somewhere in the public, there are probably people contributing to it, and you generally don't, if you're a company and you're using this component, you don't vet those people, and you probably even don't vet the code. So there's like a fairly large like attack surface where people can introduce code into your system in a way.
I think that already brings us to the definition of what your last two papers have been about, because they've been about software supply chain attacks, especially in open source software. Can you maybe tell us what software supply chain attacks are?
Yeah, sure. So I guess the term comes from like the normal supply chain, right? Which means like, I guess for a car manufacturer, they need like the engines to build a car, and then to build an engine, like their subcontractors need like, I guess, engine oil and so on. So it's like a huge chain basically spanning from before the car is built to like down to refining the metal, I guess. And there's also a similar chain for software, because software usually consists of many components. So there are like, if you're building a huge software project, there's probably some form of software from like a subcontractor, and getting to like the open source part. And if you, instead of like buying in the software you want to use as components for your software, if you like just look on GitHub or on any like other public source, you probably find open source code, and then you can take those components as like part of your software. Then you have like a huge chain, I guess, of like your software, which contains many open source components, and those components again contain many different open source components, like looking at NPM modules, for example. And suddenly you also have like a huge chain of software that spans from people you don't know into your like own software.
Okay, so you have this kind of cascading effect. If I'm like the last developer developing something, and I employ other modules from open source software, there have been people working on that software I am using in my code that even the people that wrote that code don't even know about. So
yeah, very, very likely. So especially, I mean, in open source where it's common that like people do, I guess, like drive-by commits. So they find an issue on their local setup and they fix it and they submit it to a repository, and then they never like look at it again because it's fixed. Like there are many like different code contributions from many different people that probably don't know each other. Yeah.
Okay, and that sounds risky in terms of cybersecurity. If I'm not sure who's writing code and who can change code, and I do updates, I'm not sure what will happen to that code, if that code is malicious, or if it just, I don't know, it doesn't really have to be malicious. It can just be badly written and enable someone else to do malicious things.
Okay, so I guess, yeah, for open source, there's also the like positive effect that you can look at the code, right? So you basically generally have a way to find out if someone put in bad stuff in the code. And like even if you don't check it yourself, there are probably other people that check it. I wouldn't rely on that. But like in general, you're not wanting to upsetting here many people, but like, I mean, some people even say open source code is more secure than company code, where you couldn't look at the like actual code and just get a binary, right? Because like a malicious like worker there, or like malicious subcontractor who supplied like the logging module or whatever, they also could have like put in a ad tracker or put in like a password sealer or whatever. So at least on open source, you can look at the code and see potential like malicious stuff.
So open source has the added benefit that it can be peer reviewed by just other people that will use it, because it's you'd have to be like very good at hiding code to actually build in something malicious, right?
Yeah, true.
Okay. You explained what software supply chain attacks are. Do you have an example of what they can actually look like in real life? Are those things that actually happen?
Yeah, sure. So one of the most like impactful incidents in the last years was the Sunburst incident, it's called, which was about a company that's called SolarWinds. And they had a Orion network monitor as their software. And they sold this to other companies as like a service or as a tool. And attackers managed to compromise one of the build servers of Orion. So they had like basically direct access to the source code as the releases were built, and managed to insert a backdoor. And then when like Orion was updated and the update was pushed to the customers suddenly had like a network monitor, so a tool which has, I guess, like quite a lot of access inside the infrastructure and can see a lot of important stuff like logs or passwords and so on. And suddenly all those customers were compromised because now, because the attacker managed to just compromise one build server by Orion, they were able to distribute malicious code to all of the customers that used this tool. And now like similar to the chain effect, they managed to compromise one link and they spread to many thousands of other links and were able to compromise those as well.
Okay. But this was not an open source software supply chain attack. It was just a regular software that was sold to customers.
Yeah, right. So Orion was like a proprietary source. They just managed to get like access to one of the build source. Of course, like a similar type of attack where you manage to like potentially insert malicious code in a like widely used open source component might have the same effect if like people don't notice it before like the update is pushed out, I guess. Yeah, so SolarWinds wasn't like directly an open source software supply chain attack just because like the software Orion wasn't an open source software. But just this year there was like I guess like very widely publicized, not necessarily that impactful incident in like the open source software community, which was called the protestware node IPC incident. It was about during March of this year. At the time, the maintainer of the popular node IPC library, which was used by, for example, the Unity game engine or the Vue.js JavaScript framework, decided they wanted to make a statement or a statement against Russia's invasion of Ukraine at the time. And so they decided to, in certain versions of their software, they decided to check whether it was executed on a machine with a Russian or Belarusian IP. And if that was the case, they replaced all system files on the machine with heart emojis. So they
and I can imagine it had quite some repercussions in the open source software community.
Mm-hmm. Yeah, sure. So as I said, the impact wasn't that big, so it was like quickly removed from all repositories and so on. But of course, people were pretty upset about like at least a potential hurt trust by that, right? So because if something like this happens, the trust in the whole like open source supply chain, I guess, or the whole open source ecosystem is impacted by that.
So I think it just showed how vulnerable these software supply chains can be. I mean, do you know where that code was? I think you said it. You said it was used in Vue.js and in Unity. So even if it's just a small piece of code that someone changes and it impacts a lot of people, I mean that opens quite some doors for some very scary attacks, right?
Yeah, sure. I mean, in this case, it was like really quickly spotted, and then the Unity game engine and all the other big like dependent projects, they just like froze the version and kept the version they had. So there was no actual harm done, I think, as far as I know. But of course, it shows that like if you use open software, you might be like dependent on the whim of whoever is the main maintainer of that. Like if the maintainer decides they have enough and quit the project, then you either take over or you have to find a different project. Like if you depend on it.
Yeah, and I mean that already happened in the past. I mean, for our listeners, I'm not sure if you remember, but a few episodes ago we already talked about these repositories, and especially a repository called NPM, where the left pad incident happened. I don't know. I think maybe even now Dominik might be able to explain it better than me.
Yeah, sure. So, like to quickly summarize it, the maintainer of like a lot of different popular NPM libraries, including this left pad library, had a dispute, I guess, over the naming of a package, and his package was removed from NPM, and in turn, they decided to also remove all of their packages, which included the left pad package, which was like widely used by many other packages. So like loads and loads of packages broke from that, and NPM was like forced to freeze the version and reinstate the package just so that like the whole ecosystem didn't break for like a few hours or days.
Now maybe let's get back to the two papers you actually wrote about open source software supply chain attacks. In the first one, you talked to producers of open source software, so the actual community that is developing the software. And in the second paper, you talked to the consumers, so huge companies or bigger companies that actually use open source software code in their own code, and maybe the ones that actually are hurt by software supply chain attacks. Can you maybe explain a little bit about the differences you encountered when talking to those two parties on the opposing side of the spectrum?
Yeah, sure. So I guess I start with like the, as you call it, the producer side. So the actual like open source maintainers and team leads we talked to last year. So a lot of open source projects are of course not like that big and are really dependent on external people coming in and attracting external people to the community and like growing this way. So many open source projects are actually like, at least of this, like the smaller ones, are actually focused on like quickly interacting with people, quickly accepting code from people, just so that they get a chance of having like more contributors to the project. While of course that's not feasible for like large companies that maintain in some form software. And so larger companies actually like try to audit the packages they include and try of course not to like accept code from everyone, and also try to like, even if they're devs write stuff, they actually try to like audit and test everything before they push it through production.
So if a huge company uses open source software, they not directly included, but first they have like a, I don't know, chief information officer, what was it called? Chief information security officer? I should probably know that, but I don't.
CSO, chief security officer.
Chief security officer, all right.
I guess.
And they usually have one of these, and they will check the code before they actually introduce it into their own build.
Mm-hmm. Yeah, so our finding from that was actually that there's like, I guess like a sliding scale, like with very experienced developers and small software teams on the one side who are like mostly left to their own devices. They don't have many rules around including open source code and so on. They are just like, if you find a library you think is useful, like include it, check maybe the license if it's okay for our project. And now you are like responsible for like keeping that secure. So they don't try to like slow down development too much. And while like on the other side of the scale, there are like larger companies which with like often less experienced developers, so like newer developers, I guess, just. And they actually have like specific teams that do audits, or like security vice presidents and so on, that actually like either have to approve everything you pull in, or actually like pull everything in on an internal mirror, check it, and only then you are allowed to use it in your software.
But now let's think of it this way. I'm now a malicious open source developer, and I want to break a company that I know of is using my code or my package in their code. How would I do that? So I would now go and write some malicious code into my package, and I will update it. And what will happen? What will happen to a company that is actually securing themselves against these attacks, and what will happen to a company that is not securing themselves against these attacks?
Yeah, to make it maybe a bit more closer to the real world, like let's not assume it's a malicious maintainer, right? Because that doesn't happen as often. Like, which is more generous is that there's like a malicious hacker or whatever, and they gain access to a maintainer's account or a maintainer's deployment key or something similar. So this is also why like having many people involved in open source projects could be like kind of dangerous, right? Because every one of those people is like some form of attack surface of people like grabbing access to keys or
they can lose their password. They can
like the GitHub account can be hacked if they don't like use good two-factor security or something. All right, so like just like the general threat model is probably not like that the maintainer turns malicious, like happens, but very very rarely, I guess. But more like that like third party gets access to all of this. Yeah, sure. I guess it depends a bit on which level that might happen. So like let's assume a hacker gets access to a GitHub account, but at that point they also like still like would have probably to do like a commit on the project, and people would see the code and maybe it would like reject it right at that point. So there would be no spread. Maybe they get access to some deployment keys and can push it to like a package repository like npm and so on. At that point, maybe people would notice, like if they see and check the updates and whatnot, but there's like probably a higher chance that people just pull that at like on their end from the package repository without checking it, and then they potentially have the malicious code, I guess. Yeah, and if it isn't like checked in any way or a form on like the receiving end, then it might be executed. Like there are actually some attacks that aim to like compromise those package repositories, or even like just try, like it's called typo attacks. So they take a popular package on those platforms, change the ladder, put their own package in it. Maybe they even use the original code and only change like 1 or 2 lines, which inject like their own keylogger or something. And then they hope that people mistype when they install it. So, but I guess it would be the same for someone who compromises it. So they also would try to like inject their code and include like a keylogger or like a crypto wallet stealer or something like this.
But the company that is using the code that is now like potentially being exploited would still have to do an update to get this new malicious code into their own code.
Oh yeah, true. Like I guess for most languages, you need to pull from the package repository to get code. I assume most companies, well, I don't know, but like most software teams, at least in some form, might pin their dependencies. So they like set it to a specific version, maybe not because of an attack, just so that they don't break their software in between, right? And then when they decide to update their software, they review the current versions of all the packages and then only update it. So they might be somewhat secure by that.
Yeah.
And like the next step up is probably to run like a local mirror of NPM, for example. So where you pull all updates in this mirror or in a like local build cache, and then somebody can check the local build cache and actually like audit the packages. And only if they are secure, they are like exposed inside the company, and you can then pull them from there.
Okay. You also said something that I think was really interesting. You said that the code might not even make it to the server because other people that are working on the project or are interested in the project will notice that something weird is going on with the code and it might be compromised. So I think that actually speaks like for the community because they check each other, and so it might be actually so the thing that is actually a problem that many people can be an attack vector and many people can access it and do something weird with the code is actually also a strength because other people can also catch it and stop the code from actually being run somewhere.
Yeah, sure. So for example, for the protestware incident earlier this year, as far as I know, that was like noticed in like the GitHub issue comments. Like some people posted a GitHub issue very like quickly, like hours or like an hour maybe after the maintainer updated the package. And then of course it like gets quickly publicity, and all the like packages that depend on it also probably notices or like get emailed by an interested person or whatever, and then they can like fix the version and don't update to the newest one.
Yeah. Okay. All right. But still, I mean, open source software where you are not sure who exactly is writing the code or what exactly is happening in that code. I mean, if you don't know that, why do like big companies use that code if they can't be sure that, I don't know, they might lose money over it because their servers are compromised and they're losing customer data or something?
Yeah, sure. So the biggest factor, of course, is probably for companies that open source code is generally free if it has like the right license to use for the companies. So you save a lot on developer time. You save a lot on maintenance, right? Because like the whole community maintains it probably, so you don't need to do it yourself. And if you are like using larger frameworks, you also benefit from like potential hires working on that already, right? Like if it's a bigger framework, probably people like in JavaScript or something, people have been exposed to that from the open source code. They have written their own smaller implementations or something like that. And so you can easier hire people if you want to extend it on your side.
Okay.
So I guess the benefit of open source is that it's like free, which companies of course always love. And you save a lot on maintenance. You probably like if you're using something open source, you probably can fight issues. And like in our research people actually reported that like the open source, like they love the open source openness and how well issues are resolved, right? Like if you have a support contract with like other company because you have a tool, like you might only have the, I guess like weekly support contract or whatever, and then you have to wait a week and still doesn't get resolved and so on. And in open source, apparently you have a higher chance of actually like stuff getting resolved if you need it.
And I think that's interesting just because people are passionate about software and I mean, they're not getting paid for it. They just, I don't know, they just want to do it because they think it's fun or they want to make a world a better place. It's, I think it's interesting that people are so motivated to do that.
Yeah, I think so as well. I mean, they're actually making the world a better place, right? Like, look where open software is used everywhere.
Yeah. So as a software company, can I do something to make sure if I want to use open source software, can I do something to make sure that no malicious or weird code is being used whatsoever in my end product if I just go like back down the road when it comes to like who's open source software, like just going straight back? I mean, this package is using this package is using this package, and in the end I can say, okay, I've checked them all, they're good.
So we talked about consumers and producers, but of course, in the reality, it's way more complicated, and the image of being a straight road or like being a chain, right, with links in between, like a straight chain, is very misleading because in reality, it's more like a giant bowl of spaghetti. So there are like many ends and many starts, and you can't even, if you look at it from the outside, you can't even tell where it begins and where it ends. And if you pull on it, you probably also don't get it apart right away. You need to really put in effort to pull a single strand out of there. This is just because so many packages depend on other packages, which themselves depend on packages and so on. So you certainly can isolate certain strands from that, but in the end, it's a whole bowl of spaghetti, and you only can really investigate what you have on your plate, right? As a company, right? Yeah. All the code you pull in, you can audit, I guess, if you do it locally. But tracing the whole ecosystem is probably pretty complicated. And aside from the whole image thing, there's also an actual, I guess, contract difference, right? If you are a software company and you have a lot of actual software supply chains, you buy tools and so on, and then you probably have contracts with those other companies. You probably have some form of support contract and so on. And of course, you don't have a contract if you are using open source code. And so there's no contract in an open source software supply chain, if you want to call it that.
So there's nothing that guarantees this software being online in a year or even tomorrow, and there are no guarantees that it's actually secure, and you can't enforce a contract you don't have. You can tell maintainer person XY that he or she has to keep this software up to date and secure.
Right. So I think from our research, I have the feeling that especially management has a hard time with dealing with that. They don't understand open source, and that you can't do a contract with those maintainers mostly. If a maintainer wants to quit, they just quit, and then you have your deprecated software there right there.
Yeah.
But also it doesn't work the other way around. Right. So companies form contracts, and they're in exchange for some software that's provided them, they throw money at the problem probably. Yeah. But probably even if you try, you can't throw money at all open source projects. Of course there are some that want to be sponsored, and that it's great if companies support it. Mm-hmm. But there are especially if you have bigger communities or long chains of software and so on, you don't even know where to put the money and so on. So it's also one of the main findings of our research, right? That the open source ecosystem is not your typical supply chain for companies, but that instead of trying to form contracts or trying to throw money at entities that aren't there, that maybe management should consider for the security and the health of the whole ecosystem they depend on to for example provide developers time to interact with open source or help out in open source, or maybe open source parts of the company stack themselves so that others can learn from it. Or
so just give back code to the community they profit from.
Yeah, just give back in general. It's a bit hard. Of course, it's hard to do something and have a direct effect, right? Because the whole community is a bit more distributed. You can't throw money at a problem and immediately have the supply chain saved. But if you if you ensure in general that the ecosystem stays healthy and it stays secure,
and you have those checks and balances from just people working to make it, to have this community a good place to distribute software. And as you said, they check the code themselves before it actually might go online.
I guess the more people you get interested in open source, the more eyes you have,
sure.
Looking at problems, I guess. And also the more if you keep an ecosystem healthy and open source of the software you use, you probably also there are also probably other people that use it, that get the experience in it, and those are then also potential developers you can hire. So if you just keep the ecosystem healthy and secure, in some way or like contribute to that, you probably benefit as a company as a whole from that.
Okay. Have you ever contributed to the open source community?
Yes, I have a few. Like I have not much because as a PhD we are very busy, but I have a few like contributions from like before my PhD and also like some PhD stuff around.
Okay, so you've known your way around the open source software community even before you started doing research there?
Yeah, I'd say so.
Okay.
Yeah, so actually I got like started with this whole open source thing back in Saarbrücken when I was still a master's student. So I was writing on my master's thesis, but I was like pretty bored aside from that because I was waiting for data to finish and so on. So yeah. I had all classes finished, so I decided to like just for fun take a systems engineering lecture with Andreas Zeller, who's also now at CISPA. And they like the concept was basically like different groups from like university and whatever could like pitch their project there. You could like apply for the project as a student, and then you would work like the whole semester on that. And that's actually where I met Sascha Fahl, who's now like the professor here, because they pitched like a participant management platform for like studies, right? Like a web platform where you can mention. Like parts of that are actually open source. Like I had to write some new stuff for like features we implemented there, and I like open sourced those parts.
Oh, very nice.
I think they might still be online, maybe somewhere.
So you've contributed to the company. You now try to help secure. I think that's very poetic.
Yeah, I guess in a way. I mean, it's like open source, and I joined after that only. But yeah, so.
Yeah, very nice, cool. Thank you so much for your insights, Dominik. That was very interesting. I have some quick questions for you at the end. The first one is, do you use a password manager?
Yeah, I almost exclusively use password managers, and all my whole stack is open source for this, I guess. So I use KeePass XC on my laptop. I use KeePass to Android on my phone, and I sync them using ThinkThing, which is a great tool if you want to sync stuff. Yeah, and aside from password managers, I also like have for some accounts like security hardware dongle. Like I don't like remembering passwords, I guess, and like even using an algorithm and so on gets annoying, like a mind algorithm in your head to form password. So like a password manager is like the easiest thing to like. And I mean today, if you can link them in some form between your phone and your laptop, you're good to go for basically anything.
Yeah. Okay.
And then like hardware dongles, of course, offer like way more security, and I think like it's a pretty cool technology coming up.
But you're not afraid of losing it?
So I have like for my hardware dongle, I have another one like at home. That's like at least two that work, and then after that, I think like it works now on phone, even like Android and Apple are implementing that, like WebAuthn. So,
but how does it work if you're using this hardware dongle? Does it work for multiple accounts?
Yeah, so the dongle has just like a public key on it. So you just need to activate it or place it on the account, and you can use it for as many accounts as you like. Okay. And you can also register multiple dongles per account, which is how you keep them safe if you lose one.
Yeah, okay. Okay, nice. Yeah. Have you ever fallen for a phishing email yourself?
I guess not like in general, like what you would consider a phishing email. They're like low quality emails that lead to nothing, I guess. Sometimes you get like an email with like, oh yeah, your website is insecure. Like, do you want to know more? And then it's like, oh yeah, we want to sell you stuff or something.
Yeah.
But like as far as I know, I haven't fallen like for a real phishing email.
Okay, so fingers crossed it stays that way. As a cybersecurity researcher, do you handle your private data differently? So are you very suspicious of social media platforms? Or?
Oh yeah, I barely use social media except maybe Twitter. Yeah, I generally, I guess, like try to avoid a lot of like data services that throw my data around, I guess.
Yeah.
Like you can't avoid everything, especially like in today where like the big marketing companies own like significant phone platforms and so on. But like if I can get around it, then I try with like alternative app stores and so on. Okay.
Do you like or employ smart home devices?
So I really dislike smart home devices, I have to say. I tried a smart light at home in like my bedroom, and this like it tends to lose connection to my wireless, and then like instead of like having a nice fallback mode, it starts to blink wildly, which is really annoying. So I need to switch it back to a normal light. I don't know, like in general, the idea is probably cool of smart home devices, but like the implementation and the usability are really like bad. Most of the cases like bad fallback modes and like bad apps and so on. So I'm not really convinced. Okay.
Maybe you just haven't found the right one, but yeah, I would probably also be not a fan of a light blinking rapidly in my bedroom. How do you feel about cryptocurrencies?
Cryptocurrencies, I haven't interacted much with it. Like I have maybe $15 or so. Like a few years ago, we like as a fun for like lunch, I got 15 from a friend. They are now worth like $4, I think, $4. So that's basically all I can say to cryptocurrencies.
Yeah. Okay. All right. All I can say is thank you very much, Dominik, for having me here in your office in Hannover. It was great seeing where you work, great visiting you, and thank you so much for all these insights into open source software and how you will make them even more secure in the future. Thank you very much, and keep on doing great research.
Yeah, thanks for the nice interview, and thank you for visiting us in Hannover.